And I was interested to hear a couple of comments from our speakers this morning, and it is pretty clear that our customers and our communities are looking for four things from their energy. They want affordability, they want safety, they want security, and they want sustainability. And as Sean said, we at Energy Queensland are actually also committed to a zero carbon future ultimately. Having said that, you need to get there in stages, and the initial target, not surprisingly, is in line with the government's target of 50% renewables by 2030, and you'll see that in some of the themes that I talk about. The Ergon network business, the Energex network business, the Ergon retail business, and we've now got a Eureka energy services type business. We've got 2.3 million connected customers, 700,000 retail customers. Every time I put a slide up about the amount of solar I've got connected to the network, it's wrong because the rate at which it's increasing goes up. So the 498,500 customers is more like 550,000 now. And the 505 megawatts of renewables connected in large scale, when I show you that as part of the total mix, it's still a relatively small proportion of the total amount of gigawatts we've got. It says there our total peak demand on the two networks is 7.5 gigawatts. Just keep that number in mind when I get to a slide later about the number of the amount of solar we've got. And just down the bottom left, we do have 33 isolated power stations. And I've got a lot of customers in regional Queensland, which were connected by very long lengths of small conductor. So we cover 1.7 million square kilometres, so there's plenty of opportunity to do things differently to ensure that we do meet those regional customers' expectations of affordable electricity, because, as was said this morning, everybody has the right to secure and affordable electricity. So, I was talking a minute ago about the amount of disruption in various industry segments, and it's pretty clear to see that the energy future is very much different from the energy past, and it's something that I like to talk about a lot. We need to look out the windscreen, not in the rear vision mirror, as we try to envisage that energy future. It is about electric vehicles, it is about solar, it's about energy storage, it's about IoT devices to give us more visibility and control of what's going on out there, advanced analytics, energy management. And if you take a step back and you look at that, I could talk forever about technology. I'm an engineer, I love it. But I think you've got to look more broadly than that, and it's not just about the technology, it's across those sectors. It's about the skills that are required to change in the sectors that I work in today, and it's about the skills that we need for sectors that don't exist today, because I heard Sean talk before about markets. There will be new markets and new industries arise out of the hydrogen economy, and that will require skills that don't exist today, as well as the skills that we have in their current sectors. So, I think when you look towards the future, it's pretty important to have some clear goals and some clear visions, and there's plenty of documents out there that talk about zero emissions by 2050. 2050 is a long way away, and it's hard to really get your head around what life would look like in 2050, because you've got your iPhone in your pocket. When I started in my engineering degree, the computer was about the size of a fridge. So you couldn't possibly imagine what's capable. So what we've done at Energy Queensland is we've dissected the future into a vision of 2030 of electric life, and that is about enabling Queensland customers to take advantage of new technologies. This vision is actually underpinned by some pretty sound research by Data61 and CSIRO, so we've got a pretty clear forecast for the relative penetrations of PVs and batteries and the like, and we're doing that across scenarios, and our objective is to focus on empowered customers, developments in renewables, digitisation data and market disruption, to help create an environment where customers want to take on that technology. It's pretty clear that the technology is going to happen globally because there's a global push on. The rate at which customers take it up in Queensland and Australia will be based on how confident they are that that technology can meet their needs, and it's our role at Energy Queensland to help build that confidence. So just let's have a look at some of the numbers, and you recall I mentioned 7.5 gigawatts or 7,500 megawatts. That's the maximum peak demand on our networks, combined distribution networks. Queensland's about 9,500. Right at the moment, I've got over 3,000 megawatts of connected solar to the two distribution networks. And you can see that the green bits are the larger scale, and in particularly the chart on your right there, that's the Ergon network, and you can see that the rate at which that's going up now is almost exponential. And I had a presentation from my team a couple of days ago. There's 10 gigawatts of potential large-scale generation projects in the pipeline for connection to the distribution networks. That excludes the transmission network projects. As well as that, you've still got mum and dads putting solar panels on their roof. You've got small businesses putting solar panels on, and increasingly we're looking at residential multi-tenancies looking for ways to put solar in their roofs as well. So this is a continuing trend which we need to enable through repurposing the network to meet those challenges. Oops. So it's worth just having a look at seeing where the grid scale generation is, because Queensland's a big place, and I just showed you the chart about the rate at which it's connected to the distribution network. And I think it's really instructive to see on the map that pretty much the bulk of that generation is happening in regional Queensland, not surprisingly, because that's where you've got plenty of spare, you've cheap land, you've got plenty of sun. The problem is you don't have that many people, you don't have really strong networks, and most of the demand for electricity is along the eastern seaboard, and clearly that's concentrated in southeast Queensland. So how do you get energy from where it's generated to where it's used? And if I step forward in my speech, how do you get energy from where it's generated to where you want to create hydrogen? Because my take on it is that to have a viable hydrogen industry, you need to have facilities where there's water. If you're going to have ultimately green, so you need water, you need access to cheap electricity. Unfortunately, that cheap electricity might be quite a long way away. And if you're going to export, and it's my understanding from a few of these conferences now is you need a domestic market and an export market, and you could have plenty of debates about which one comes first. I think they probably need to go together. You're going to need a port. So, it's pretty clear that the port facility is going to be on the coast. The solar's not on the coast. So, another interesting fact is that our network is now already running backwards. So this chart here shows a large substation in the Wide Bay region. So that's sort of what I call a bulk supply substation. So it supplies the whole of that Wide Bay region, and it's at minus 57 megawatts in the middle of the day now. And there are 300 megawatts of grid scale projects yet to be finalised. And that area already has probably one of the highest penetrations of rooftop PV in the world. So, the debate nationally is about making sure that you get stability in the network and grid firming, and you hear people talk about frequency control and all that sort of stuff. There's a whole bunch of other technical challenges that we need to solve across the full supply chain to make sure that we can integrate this level of renewable while maintaining reliability and security of supply. So how does that fit with the hydrogen industry strategy? And I think that I'm going to talk about that in two parts. And the first part is about how the distribution networks need to enable the hydrogen by as I said, connecting energy sources to the hydrogen production facilities. And it's also clear, and I think that we've already seen from some of the early speakers, that hydrogen production can help stabilise the system during peak demands because it's a load. You can store it up. You can then use it to generate. So it can be both a loader and a generator. Depending on the economics of the plant, you could you could actually have it as a controllable load, or you could have storage at the, energy storage at the plant. What I do know is it can play multiple roles in the energy supply chain, and I think that's one of the key opportunities I see with that technology relative to other technologies, because battery technology, as we've already heard, is a critical part of the supply chain, and it's already delivering benefits in South Australia in terms of grid firming. Having said that, there's a limited amount of energy you can store cost effectively in lithium-ion batteries. So one of the things we haven't spoken about as much is the technology. So we need to, the network was never designed for power to run backwards. Now, it's not actually that, physics isn't really the problem here. You can have power running backwards, but you do need to change the way that you think about controlling the amount of visibility you have, the technical platforms you need to exercise control, work with customers who want to exercise control so that you can make sure that you manage all of the challenges of running a system effectively with generation everywhere, because that's a far different challenge from the days when generation was in a few small places and then you had customers in 2.2 million cases. We're quickly getting to the point where I've got generation in as many places as I've got customers. So storage is no doubt a critical aspect of a future with lots of inverter-based generation. So this chart was produced by Data61. It's one of the charts from the information I presented to our board to underpin our strategies. And you can't see all the numbers. You'll no doubt get them when you've got the side plate. The key point is the shape of the curve as it goes exponential out towards the right there. And it pretty much says that once you get to a certain tipping point, you need storage on the network to deal with the high level of that intermittent renewables that comes from solar and wind. You need to make sure that you can store it when you're generating it, and you can also then from that storage generate it when the solar and the wind isn't working. So storage is critical. Batteries alone don't do the job. Hydrogen can support and complement the short-term storage capabilities of batteries. So, it's good that I chose to talk about decarbonising remote power stations. Given the earlier presentation, and it is pretty clear to me, and we've been doing a lot of work in remote area power stations with regard to integrating solar. Hydrogen can clearly complement solar batteries and wind to deliver security. What really started to get my attention was that hydrogen is now at cost parity with diesel for heavy transport. The diesel engines we've got in remote area power stations are effectively the same diesels you put in heavy transport. So I think the time's right to get out there and prove that concept works. So just a couple of pictures, and just to reinforce the use of diesel. We use about 30 million litres of diesel per annum. Some sites have got 1 million litres of storage to cover the wet season. I personally have some challenges with having that level of diesel in the Great Barrier Reef Marine Park. Having said that, you do need to be mindful that it is a long way from anywhere in these communities. They suffer from extreme weather conditions, and at the moment, without some form of energy storage, in this case diesel, you can't deliver secure supply with simply solar, wind and batteries. It's not possible. The other little problem I've got from an economics perspective is the delivered cost of diesel. You need to factor in this federal government rebate, which clearly distorts the economics relative to what mum and dad see for the cost. So, it's an interesting policy position we've got with regard to diesel fuels versus low carbon fuels. So I do think we need to progress hydrogen as an option in those facilities, prove the concept up, and I really do like the modular concept because it's something that we already do with the diesel engines, and creating a scalable modular system is an efficient way to go. Where am I up to here? This one. So so it can deliver resilience. It's about how you integrate that in. So you don't just, we're not going to just be able to flick a switch and have it all of the isolated systems convert to hydrogen overnight. You do need to start somewhere, and my take on it is that island communities, places where you've got access to water first, because I do think it's about potentially you could use hydrogen. I might just go to my next slide. I think this slide, this little graphic's a little bit like the one that was put up before for the Griffith site. So you've got solar. You can either generate the hydrogen on site with hydrolyzers probably, or you could ship it in a storage facility. Either way, you've got to have some hydrogen storage in your facility, and then you can convert that hydrogen into electricity. And my take on it is there's at least 3 different technologies that you could use. You could use fuel cells. You could use small gas turbines. You could use an engine like they use in heavy transport. There's probably some other technologies I don't know about yet. What I do know is that then you can then have to tie that in with the customers, because you've got some poles and some wires and some solar panels integrated, and there's going to be some challenges in making sure that hangs together so that you can get that demand-supply balance and the system remains stable. So they're the things that we're working on at the moment in terms of integrating PV into the diesel system. As we get better at that, then I think it'll be easier to integrate hydrogen type facilities in. I did do some economics on a standalone hydrogen facility, and from a very large supplier of hydrogen type capabilities, multinational company. It was about 60 million capex versus maybe 5 to 6 million for a traditional system. So if I ran the NPVs out long enough, it might have stacked up. That situation will change dramatically, as we've heard this morning, as you get scale, as the equipment gets more efficient, then the economics will change, and you've got to start with some pilot projects, and then you've got to move into scale. So my last slide, and I just need to get this build up, and I've sort of whizzed through this because I think that the material that's in here is easily readable. I just want to restate the fact that I do see hydrogen and smart networks working together is the future for the energy sector in Queensland. I do think that Queensland's well placed with very large reserves of solar capability, and we already demonstrated through the CSG LNG industry our ability to export product to overseas markets. We will need to rethink some of the design fundamentals and deliver the simplest solution that optimises the existing network capacity. I go to a lot of forums and I hear a lot of people talk about really complex problems. I think we can get paralysed by complexity. So thinking about the problem in small chunks 2 or 3 years in advance, doing what you should do now in preparation for what you need to do next is the philosophy we have for integrating solar into our network. And the 2 networks in Queensland already have got higher penetrations of solar than any other distribution network in the world, I would suggest, particularly in grid scale. Ergon's rapidly jumping ahead in terms of rooftop PV. There's no other place that's got higher penetrations of rooftop PV. And we've done that without spending very much money because we've done simple things first. Grid scale PV will underpin the 50% and ultimately 100% renewables outcomes that the communities need. There's no question about that in my mind. Technology combined with skills is required to accelerate that transition. And hydrogen smart networks working together is the future. I'll say that again, because it is clear that you need cheap energy, and effectively solar energy's got a zero marginal cost once you put the plant in. So it will ultimately come down to scale and economics, and I'm sure we'll hear more about that from some of the speakers later on. I'm happy to take questions, or I'm happy to give the lectern back to the organisers to get on with the next speaker.
Just one thing.
Sure.
Two questions. First,
Just two.
Who's taking into consideration the cost of development and then the ultimate disposal of all of the solar panels that are being used? Because they do have a lifetime and there are toxic components both in the production and in the recycling. And the second one is we seem to be hooked on the current that we deliver, which is 240 volts at 50-60 megahertz. Do you think that there is now a position with the change in electronics where just about everything you buy has a step-down transformer, that we actually move to a lower requirement of power for most items in delivery? So the air conditioning might need a higher energy rating, but most things will run on a much lower energy rating than being delivered.
Two very good questions, and I'll give you my personal opinion on both. So the first question goes to solar panels and whether we're adequately thinking about how to recycle and deal with those panels when they reach end of life. Because depending on where the panel came from, it might be 10 years, it might be 20 years. I think you can broaden the question out, because I think the same question can apply to battery technology as well, and that there's a finite amount of resources that are available to produce solar panels and produce batteries. You're already seeing recycling as a key opportunity for batteries, and I think that's probably driven by the rate of EV take-up. Inevitably, it's my view that the market will respond to the need to recycle solar panels and create new uses for the material that gets recovered, because we will need to be mindful of that. So I agree with it's a key point. It's certainly not something that we at Energy Queensland are focused on, but I'm sure that that will emerge as a market opportunity for recycling. On your second point, it's a question that sometimes I jokingly talk about is moving back to DC, because you just made the point that my iPad's running on DC. Most of the electronic devices in your home are running on DC. Having said that, the energy sector as it's designed today was sort of imagined back in the 1900s to 1930 period, where a lot of people innovated to get to it, and they use AC and they use high voltage AC to get power over long distances from generation to customers. Just in Queensland, you've got $25 billion worth of network that's been built to create that, and that excludes the cost of the infrastructure in the homes. So while I think it'd be neat if you could start putting DC circuits in homes or using DC as an alternative, I suspect that it's in the short to medium term, it's not the next logical step that you'd take to move to a lower carbon future, because it's actually one of my big challenges is getting power from solar, like a 100 megawatt solar farm, over pretty skinny 66 kV or 132 kV networks. So I think AC is here for a while. I think high voltages are here for a while. You've got a lot of homes out there that are wired for AC. So I think the smartest thing we can do is to figure out how to get the best out of that technology. And I think that's what Sean was talking about this morning. I think it's about how you make the current technology deliver what you need in the future, not throwing it out and trying to start again.
Thanks, Peter.
Thank you.